a rubidium atom, a Rb plus ion has. So if it has a positive charge, right? What does that mean? Well, the only particles that can move are electrons, right? And electrons have a ding, ding, ding negative charge. So if rubidium has a positive charge as the ion, that means it lost an electron. Okay, so if the ion has one less electron, the atom actually lost the electron. Now the ion has less electrons, so the ion would be smaller, correct? So that should make sense, right? Now it's smaller, why? It's smaller because it has less electrons, right? 36. Which ion in the ground state has the same electron configuration as an atom of neon in the ground state? What I'm going to do is look up the atomic numbers for each of these. So potassium for the atom has 19. Lithium for the atom has 3. These are the atomic numbers, so that's the number of protons and the number of electrons in the atom. Fluorine has 9. And chlorine has 17. Well, this is talking about the atom, right? So if potassium has a positive ion, it lost 1 electron. So it now has 18. Lithium with a positive charge has lost 1 electron. So it has 2. Fluorine with a negative charge has gained 1 electron. And chlorine with a negative charge has gained 1 electron. So let's go back to the periodic table and look down group 18, the noble gases. What else do we have to know the name of? Group 17 is the halogens. Group 2 is the alkaline earth metals. Group 1 is the alkali metals. And groups 3 through 12 are the transition metals. Okay, so if we look at these noble gases, you can see that, well, first, helium has 2 electrons, neon has 10 in the atoms, right? Argon has 18, krypton has 36, and so on. So my question was asking which one has the same electron configuration as neon? Well, neon has 10 electrons. So which ion ended up with 10 electrons? Yeah, fluorine. Which substance cannot be broken down by a chemical change? So this, we are looking for an element. Compounds can be broken down, elements cannot. Now, if you don't recognize the name of the element, what should you do? Go to table S and start scanning the names, okay? And one of them you will find on that list. And eventually, if you didn't know it already, you will find out that it is barium. Number 38, the difference in which property allows the separation of a sample of water and sand using a filter paper and a funnel. So here's a beaker, we've got a filter paper, we put sand and water, sand gets stuck on the filter paper and the water goes through. So what different properties do they have? Well, they have a difference in particle size. Particles that are too big get caught on the filter paper. Number 39, according to table F, which compound has a very low solubility in water? Well, first of all, it said table F, so please come on now. I hope you know that you should turn to table F. So let's get there. Here we are, table F. Very low solubility. So if we look at the bottom, right here, insoluble really means the ones that have very low solubility. So we're looking for something that is insoluble, okay? So we have sodium, sodium, and calcium, calcium. So let's look at table F. You could see this. If you don't remember, if you don't know that this is sodium, you're going to have to look that up on table S, find it here. But if you see that sodium is here with no exceptions, meaning sodium is always soluble. So these are both wrong, okay? Now, either calcium hydroxide or calcium phosphate is my answer. So I have phosphate and I have hydroxide here. I don't have calcium in any of the rules. So you can see that phosphate has exceptions, but it's group 1 and calcium is not in group 1. If you don't remember that, then you just look. Here's calcium in group 2, not in group 1, right? So let's go back to table F. And calcium is not this. So let's check hydroxide. Oh, look at this. Hydroxide, when it is with calcium, has an exception. That means it is no longer insoluble, it becomes soluble. So the only one that stays insoluble is calcium phosphate. All right. Number 40. What is the molarity of a NaOH solution containing 0.125 moles of NaOH in 0.200 liters of water? Okay, so let's go to the formulas. And we have one for molarity, moles divided by liters. So moles divided by liters, right? So let's open the calculator. Moles, 0.125, divided by liters, 0.2, is 0.625. And that is an answer. It's always a good sign when we do the math and we get the right answer. Number 41. Compared to a 0.10 molar aqueous NaNO3 solution at 1 atmosphere, a 1.0 aqueous NaNO3 solution at 1 atmosphere has, well, look, we have lower and higher, and we have boiling point and freezing point. So remember, here is thermometer. So 100 degrees Celsius is the boiling point of water. 0 degrees Celsius is the freezing point. When we add stuff, the boiling point goes up and the freezing point goes down. It goes up more when we add more stuff, and it goes down more when we add more stuff. So if we're comparing it to this one has more stuff. It has a bigger molarity. So it would have what? A lower freezing point and a higher boiling point. Number 42. What is the temperature in degrees Celsius of a sample of matter at 35 Kelvin? Well, that's a formula question right here. Okay, so K equals degrees Celsius plus 273, right? I know my Kelvin is 35 equals degrees Celsius plus 273. So I need to subtract 273 from both sides. So 35 minus 273 equals negative 238. Number 43. Which graph represents the relationship between pressure and volume for an ideal gas at a constant temperature? Well, the relationship between pressure and volume is that when pressure goes up, volume goes down, right? So if we have, this is low pressure but high volume, this would be high pressure but low volume. So it's got to be this one. That shows that inverse relationship. Number 44, which equation represents a physical change? That means I have the same exact stuff, the same exact chemical formulas on both sides. So yes, I have the same elements, but those chemical formulas are not the same. Yes, I have the same elements, but those chemical formulas are not the same. Here we go. Those chemical formulas are the same. The only thing that changed was the state of matter, and that makes it a physical change. Number 45. Which combination of reactants would result in the fastest reaction rate? Well, first I'm going to look, I can either have strip of zinc or powdered zinc. Which one reacts faster? Powdered, because it has a greater surface area. Now, the other thing I could have is a 2 molar or a 0.2 molar. Which one would react faster? The 2 molar, because the 0.2 has a lower concentration. So powdered zinc with the higher concentration would react the fastest. Number 46, which equation represents a redox reaction? Well, the easiest way to look for a redox reaction is look for single elements on one side that are combined in a compound on the other side, like this, single element, but a formula on this side. That means oxidation numbers had to change. Okay? Number 47, which equation represents reduction? So remember we practiced this just drawing a quick little number line, 0, 1, -1. We put an arrow across this way, that represents Leo. We put an arrow going backward here, that represents Ger. The arrow points to the side of the equation we need the electrons. So if it's reduction, that's Ger. Look way the arrow points toward the reactant side. Here, electrons in the wrong spot. Here, electrons in the wrong spot. Okay? Now I have to decide between these two which one is correct. So now I check for, does charge balance? 0, -1, +1. No, those two sides are not equal. What about this one? +1, -1, and 0. Yes, because +1 and -1 equals 0. So we had to have electrons on the correct side of the equation, and we had to have balance of charge. Okay. Number 48, the pH value of a solution is changed from 6.0 to 4.0. Which phrase describes the change in the hydronium ion concentration of the solution? Well, first you should know that pH is based on logarithms, and logarithms are based on 10. So it can only change by factors of 10, which means 10, 100, 1,000, and so on. So that means these are wrong, right? Now, the hydronium ion either increased or decreased. So here's pH from 0 to 14. At 14, we have the most hydroxide. At 0, we have the most hydrogen or hydronium, because remember, hydrogens just like to stick to water molecules. So I have more hydrogens the closer I am to 0. If I went from 6 to 4, do I have more H's or less H's? Well, I moved this way, closer to 0. That means I have more H's, right? Number 49. What type of cell is represented by the diagram and what change occurs? Well, first of all, bzzz, see this power source? That means it's electrolytic. So these are wrong. Now, what energy change happens? Well, think about this. The power source is providing electricity. So we start with electrical energy. Okay. And that electrical energy is what produces the chemical change. Okay. And then number 50, which equation represents nuclear fusion? So fusion is when you take two little nuclei and put them together and make a bigger one. So this started with one nuclei, wrong. All right, these two, which is too little making a bigger. That's this one. This would be fission, and these two would both be natural decay or natural transmutations. And that is the end of the multiple choice.